Hey guys, today I'm going to be analyzing Canadian rental housing prices. As we all know, since the pandemic and more intensely in the last few months, we've been experiencing a huge housing crisis here in Canada. So that's why I wanted to take this opportunity to explore some rental housing data and how to leverage it into a Streamlit app. So I sourced data from the CMHC Federal Organization, which is the Canadian Mortgage and Housing Corporation. I extracted the data using the CMHC R Library, which actually is an API wrapper that extracts data from the CMHC information portal. Now you can obviously use this R library directly to process the data, but personally I use the rpy2 Python library to actually run the R code within Python. I'm not going to go into details on how to do this in this video, but I may make a video on this topic alone because I think it's a useful tool to know. Okay, so as I just mentioned, I use the rpy2 library that includes an import module to import specific R libraries. So in this case, I wanted to import the CMHC R library, which I then assigned to an object to be able to use it. Now the functions of this library obviously return R objects, in this case R data frames. So I had to create a function that transformed these R data frames into pandas data frames so that I'm able to continue coding in Python only. So the CMHC library provides a way to extract geometries of the Canadian Census subdivisions, or CSD. You only have to use the getCMHC geography method that actually creates a geodatabase file to a specified path. So once it is created, you can access it with the GeoPandas read file method. And then we're specifying here that we want to use the CSD layer. And then we have this geodata frame that is created, which includes all the CSD IDs with some information on them. We have the name or, for instance, the centroid of the area. Now, once we have the list of geo IDs we're interested in, we can proceed to create a for loop and use the getCMHC function to extract the data. So here I decided to extract two main metrics. So we have the average rent and the vacancy rate. So the parameters of the function are pretty straightforward. You have to input the right survey, series, dimension, and breakdown, and we're going to be looping on the geo IDs. So for instance, here we're going to be extracting from the RMS survey, and we're going to be specifying the average rent, which will be broken down into bedroom types, and we're specifying here that we want the historical data. As I mentioned earlier, the function, the getCMHC function outputs a R data frame. So we're going to be using the R2 pandas function that I created earlier to transform the object back to a pandas data frame. All right, so with the data we have just extracted, we can start building the Streamlit app. First things first, we're going to import the required libraries, and then we're going to set up the general app config like so here. So the app looks like this for now. We just have the title, obviously. So yeah. Then we're going to load the data we just talked about using the cache data decorator. So here we have the census subdivision dataset. We're also going to import the average rent and the vacancy rates. So here we're actually pivoting the dataset to have the bedroom types into columns instead of rows. So we do the same for the vacancy rates. And then we merge these three datasets together to have one single metrics dataset. Side note here, I created a custom function to actually transform the metric columns into colors so that we are able to display the metrics with a color gradient based on the value in the map visual that we're going to see in just a minute. So the dataset looks like this. We have all the geo IDs here for which we have the time series of the average rent by bedroom types, and we have the same for the vacancy rate by bedroom types. Next, we're going to be adding the selector widgets. So I wanted to be able to select various bedroom types for each metric. I first created a metrics dictionary to be used in two different select boxes component, like so here. And I'm also using the date column from the metrics dataset to create a date selector with the select slider component. So by doing that, we get these widgets here. As you can see, each inputs actually update the value of their assigned variable. So if I select here or the date here, it updates the assigned variable. Now, I wanted to have a broad view of how both metrics evolved through time and across all CSDs. So I decided to create a line plot which displays the average value across all CSDs for each date and created intervals representing the distribution of 95% of the CSDs. So I use the Plotly library to do so. So we have the line plot here, and I'm adding the upper and lower areas with the scatter method. And then I wrap the output figure object into the Plotly chart component to display the plot. So ultimately, the plots look like this. Again, you have the average value for both metrics and the upper and lower bounds. Now, as for the map visual, this was created with Folium. So let's see what it looks like. So I use the dual map method here to actually create two side-by-side map to compare the distribution of average rent compared to the vacancy rates all across Canada. So I decided to set the background layer to be the Carto database positron. So I used the GeoJSON method to display both metrics. I decided to set up points or circles as markers, and the color gradient was determined based on the color level equivalent to the value of the metric. So this refers to the custom function I created earlier, which created these columns in the matrix dataset. I also added a simple tooltip to be able to see the average rent when you hover over the points, and added the feature to the dual map here. Something to note here to specify on which map you want to actually add the feature between the two maps. You only have to specify either M1 or M2 if you want to display the feature on the left one or the right one. Finally, to display the map in Streamlit, you wrap the Folium object within this function here, the Folium static function, and it will display the map. Regarding the legend that I displayed above the map visual, I actually couldn't find a way to display each of them respectively on the right and left hand sides of the dual map. So I had to create a custom legend with the Branca library and the linear color map method. So this is what this chunk of code here actually do. So after merging all these sections together, we get this final product here that looks like this, and we can start analyzing the data. So for instance, if we select the average rent price regardless of the number of bedrooms, same thing with the vacancy rate, and for the latest data that we have. First thing that we notice is that the distribution of rent prices across all CSDs seem to widen across time, meaning that we have a much wider range of prices in the recent years. There also seem to be somewhat of a constant in cheaper average rent prices, while higher rent prices tend to increase much faster. Now, as for the vacancy rate, this is where we can clearly see the crisis coming alive. So since around 2017, 2018, there seemed to be a drastic drop in available units, where the average rent price drops as low as 1 or 2% as of October 2023. As for the geospatial aspect, without surprise, the average rent prices is higher in big cities. So like Toronto, Montreal, and we have Vancouver here. Obviously, these prices are higher, but this can still be observed across Canada. As for the vacancy rate, again, this seems to be a Canada-wide issue as for the low vacancy rate. Now, as we can see here, Saskatchewan seems to have the higher end of the vacancy rate, meaning that there seem to be more available units in Saskatchewan. Now, if we want to compare the map distribution on a timely aspect, um, we can note that 15 years ago, the highest average rent prices were roughly 3 times higher than the average lowest rent prices, while if we look at today, it seems that the ratio is more 4 to 5 times higher. As for vacancy rates, there seems to be a much wider availability across Canada compared to today. So yeah, that concludes what I wanted to show today, which is leveraging some rental housing data into a Streamlit app to actually extract some insights on the current housing crisis. I hope you guys enjoyed this video. Don't forget to like and subscribe, and I'll see you in my next one. Bye guys.